Very well. I wish to welcome you all to this fifth webinar jointly organized between the Norwegian Open AI Lab and the NORA, and this time it is with NORA.startup. We have called this webinar Sound, Audio and AI. My name is Trym Holter and I'm the director of the Norwegian Open AI Lab. Having worked on sound, audio and AI in some shape or form during my entire professional career, I find this personally a particularly intriguing field. And sound and hearing has always been incredibly important to us humans. It is our most important means of communication. It is a great source of joy and other emotions through music. And during the past century or so, we have also figured out ways to use properties of sound to sense and understand the world around us, to measure things. So despite how important sound and audio are to us humans, we, or at least I, still see how it is sometimes underrated or not given the priority it deserves. And I would say particularly in the context of technology. And I think the most obvious example of that is coming from our current practice of virtual meetings. So people, I apologize in advance for this rant, but please put on your headsets or make sure in some other way that you have a good close talking microphone in those meetings. The laptop built-in microphone is not doing the trick and you are causing people to struggle. As I said, sorry about that rant. Norway has a long-lasting tradition of companies working with sound and audio, from the radio and hi-fi manufacturers to video conferencing equipment, measurement systems, medical devices, hearing protection, underwater communications, and industrial acoustics. During the last couple of decades, we have seen also in increasing numbers of startup companies working on various aspects of sound and audio, and some of them with great success. It is not surprising, I think, at all that during the last few years, the opportunities linked to artificial intelligence is to an increasing degree being used and applied in sound and audio. And today we will meet some of the newcomers doing exactly that. Finally, just a very brief footnote for the sake of transparency. I'm on the board of directors and a small-scale investor in one of these companies we're sitting here today, namely Nomono. With that, I hand it over to you, Morten.
Thank you, Trym. Artificial intelligence is transforming a wide range of industries, and the world of video and image analysis has been the center of AI the last decades. However, images are not enough, and many will argue, Trym including, I think, that hearing, not seeing, is believing. As Trym said, Norway has fostered many successful AI companies within sound, and today we will hear from some of them. In this week's NORA.startup NAIL webinar, we will meet Øystein Birkenes, from audio software engineer from NEAT. We will meet Audun Solvang, CTO and co-founder of Nomono, and Iver Jordal, senior machine learning engineer, also from Nomono, and of course, Jon Nyrby, head of data science and machine learning in Soundsensing. And we're here to discuss sound, audio, and of course, AI. My name is Morten Goodwin, and I will chair this session, but this session is mostly for you, the audience. Today, we will have a short presentation from each of the companies, and then we will have a panel debate later on. So that means that any question you have as an audience, please put that in the chat, and we will try to think of any of the good questions to give to any of the good panelists, because this is first and foremost information for you, the audience. We ask questions. The first one out that will give us a short explanation of NEAT is Øystein Birkenes. He has a PhD from NTNU in Trondheim and has since 2019 been in NEAT, the recent startup company that makes elegant video collaboration system for Zoom, where he develops audio processing algorithms based on machine learning. So Øystein, it's very exciting to hear what you have to tell us. And in the meantime, those that are not Øystein, we can close our camera. Øystein, what would you like to tell us about NEAT?
Well, first of all, thank you, Trym and Morten, for the nice introduction and for inviting me to this very exciting webinar. So I'm Øystein, and I work for NEAT, which is a Norwegian company and maybe one of the hottest tech startups in the world at the moment. So we make elegant video systems for Zoom, which is a video conferencing service that no longer needs any introduction. Everybody knows about Zoom, and everybody has now tried the power of video conferencing. So here is our first product. We call it the NEAT Bar. It has a high quality camera, loudspeakers, a microphone array, and powerful internal compute. The NEAT Bar comes with a controller device, which we call the NEAT Pad. And the NEAT Pad also has loudspeakers and microphones. So the NEAT Bar is made for the meeting room, but it also works great for the home office. I'm currently using a NEAT Bar right now. But we're also working on some new products, and some of the new products are maybe even better suited for the home office. Like the product that you can see an early mock-up of here. We call this product the NEAT Frame. And the NEAT Frame has a beautiful touch panel. It has a powerful camera. And of course, it has loudspeakers and a microphone array. And the NEAT Frame is only one out of 3 new products that we are going to ship this fall. All of our NEAT products make heavy use of machine learning, both for video processing and for audio processing. In video processing, we detect human bodies and faces so that the camera can automatically follow you and frame you in the best possible way. In audio processing, we use machine learning algorithms for all the core algorithms, all the core components, sorry. We use it for echo cancellation, for stationary noise reduction, and for automatic gain control, just to name a few. And most of these models are trained in an unsupervised way, meaning that they don't need any human labeled data, but instead the models, they can extract knowledge from the continuous streams of audio samples that become available on the system. And there are streams coming with audio samples coming from the microphones. And there is a stream of audio samples coming from the network, which is the signal that is played out on the loudspeaker. Learning in these models is done in a so-called online or incremental fashion, which means that the model parameters are updated every time a new data sample arrives. In this way, since these models learn continuously, they're able to adapt to the different acoustics in the room and to the changing acoustics in the room, and also to the different voices and noises. I will give you one example of a problem that we are solving with unsupervised learning that we're currently working on, and that is to remove sound sources that are outside of the camera view. Because the sound sources that you cannot see are most likely noises, and we will try to remove them. So I will demonstrate for you what I mean. And for that, I will need help from Alexa here. I'm going to ask her to count to 10, and then I will move her out of the camera view so that you will be able to hear that our model is able to suppress her voice when you can't see her. Amazon, count to 10.
1, 2, 8, 9, 10.
So this is a feature that we can describe as what you see is what you hear. In addition to unsupervised learning, we're also working on supervised learning with deep neural networks for some of the more challenging audio problems. And one of these problems is to remove non-stationary noises like the clicking noises from my keyboard or the noise from this bag of potato chips. And this is a problem known as deep noise suppression, and a problem where we have witnessed a tremendous progress over the last few years. Some of the state-of-the-art methods are now so good that it almost feels like magic when they do their thing. So in summary, our audio processing algorithms we do here in NEAT are almost exclusively based on machine learning. And this has been a deliberate strategy from the beginning. The shift from signal processing to machine learning has opened up new doors for us and enabled us to do things differently and in a better way. But there's still loads of untapped potential here, and we need more people. We need more people who can help us to make audio sound even better with the use of machine learning. So we are currently accepting applications from both junior developers and senior developers. Thank you.
So thank you, Øystein. So finally, I can start eating potato chips in my Zoom meeting without destroying the meeting. That's something I've been looking for a long time. Good. We'll of course have a lot of questions for you, but I have one immediately. So you talked about incremental learning, that the machine learning algorithms are incrementally becoming better over time. A common problem with that is that you have something called catastrophic forgetfulness. You kind of forget something that used to be very useful, but when you learn something new, you kind of forget the old one. Is this something you struggle with?
Not really. The methods, they learn from the new data that comes in, but we also need to forget the old data because they become outdated. So we are putting most emphasis on the most recent data that come in. But of course, we have to be really careful so the models don't get stuck somewhere. We need to control that, and we need to really understand the stream of data that is coming in.
Very good. I'm sure there's a lot of questions burning in the audience as well. Thank you for now, Øystein, and we welcome you back in the panel in a few minutes, because now we're going to meet with Audun Solvang and Iver Jordal from Nomono. Audun is CTO and co-founder. He received his PhD in telecommunications in 2009 from NTNU on the topic spatial audio. And he is CTO and co-founder of Nomono. Iver is Nomono's 7th employee. He's a senior machine learning engineer and currently focuses on AI tech to improve audio recordings. And we're very much delighted to hear more about Nomono. So Audun and Iver, the floor is yours.
Oh, thank you, Morten. So Nomono is a spin-out out of SINTEF. We were established in 2019. We are now a cross-disciplinary team of 25 individuals. 6 of us are working on signal processing. So why do Nomono exist? Well, we see that next generation audio, the next future formats are coming, meaning that we are now starting to experience object-based audio, which is kind of a paradigm shift in the audio. And this means that the workflow creating this or capturing this kind of audio, that is quite a cumbersome affair. And storytellers don't want to focus on technology, they want to focus on being storytellers. So what we do, we are creating an easy to use hardware and / software tool for the storytellers to capture this object-based audio. Object-based audio is basically the core of audio formats such as Dolby Atmos, MPEG-H, Sony 360 Reality Audio. So what does this mean? Well, if you then have this object-based audio format in the reproduction stage, you are then able to interact with the content. So for instance, you may be able to suppress the ambient sound objects and focus in on dialogue, which is a really good value for the speech impaired group of people in the society. But also you have spatialization, spatial audio. That is also a part of this this new paradigm shift. And we see this with Apple focusing on that, for instance, right now. This means that the listener will be experiencing being a part of the story being told. They are immersed, creating this emotional connection to the content. So rather than saying hearing is believing, you might say that spatial hearing is feeling. This is triggering some emotions. So these sound objects, they represent sound sources, meaning you need tools to provide close to anechoic multi-channel content with very high quality. So this means noise reduction of different kind, crosstalk reduction, but also metadata, collecting that according to these formats, but also beyond that. So for instance, sound source localization, active speaker detection, different classifications such as speaker diarization and speech to text, being able to transcribe your content is of importance. So we were very lucky to get Iver on board. It was 1 year or something like that after we kicked this off. So I'll hand it over to Iver to talk a little bit more about the machine learning.
Thank you. I joined the company to develop machine learning technology that can enhance audio recordings in various ways. One of the things I do is making noise reduction models that input noisy audio recordings and output enhanced audio where the noise is reduced while the dialogue is kept intact. Now I'll briefly mention some of the challenges I face while doing this. First, speech enhancement technology research is typically performed on mono 16 kHz audio. This also means that most open data sets out there are in 16 kHz mono. Now this is an issue for us because we deal with not mono but multi-channel audio, in other words multiple microphones. And we don't deal with low sample rates like 16 kHz but with high sample rates like 48 kHz. In other words, we need to go beyond what many audio AI researchers are doing. One of the things we need to do to go beyond most research today is curating high quality data sets with high sample rates in-house. While we do need a lot of data, we also should keep it balanced and diverse in terms of aspects like language and gender. And for this reason, we keep track of dataset metrics such as gender ratio as we add things to the dataset. Since multi-channel recordings are hard to obtain at scale, we generate or simulate multi-channel recordings from mono recordings. We simulate a number of noise sources and a number of people speaking in different positions in a room. And we also simulate the room acoustics. In a way, we generate recordings that are degraded while still having the ground truth of how it should ideally sound. And to do the world a service, we have open sourced the core part of this code, the degrades or augments audio. And it's currently the world's most popular open source audio data augmentation library for Python. It's called Audiomentations. And one of the benefits of open sourcing this is that other people from all over the world are actually helping us make this library better. Lastly, metrics is a challenge. A metric in this context is a number that says how good an audio snippet sounds. Some objective audio quality metrics exist, but they do not always match very well with human perception. Another challenge is that we cannot always optimize for good audio quality metrics directly. And this is an actively researched area. While our machine learning models need objective and mathematically well-defined metrics to optimize for, we also perform listening tests with humans that evaluate the sound quality. And we have tools for this process. That's all from me. Back to you, Morten.
Thank you both. That's very interesting. One question that immediately springs to mind is, since you involve so much synthetic data, how do you ensure that this data is actually representative for the audience that you are addressing?
We tweak the system as we go. We test our system together with some early users, and we get feedback. For example, some people might say it doesn't work well enough in volleyball matches, or it doesn't remove this music background noise well enough, and then we'll add more of this type of data to our data sets. So it's an iterative process that never ends.
Never ends in a good way, I would assume, because that's what you want life to be like. Perfect. Thank you. From you, we welcome you back to the panel in a few minutes. Audience, please remember, if you have questions, please post them in the chat and we will provide them in the panel debate. The last speaker today is the one we've been waiting for, Jon Nordby, Head of Data Science and Machine Learning in Soundsensing. He's a machine learning engineer with 10 years of experience developing software for embedded systems and data processing in audio and images. Soundsensing is a leading provider in IoT sensor systems using sound as a primary data source. So Jon, we're very excited to hear about Soundsensing.
Hi, thank you so much. And I believe Birte is showing slides for me. So can you see slides?
Yes, we see them. Soundsensing on edge audio analytics. We're very excited.
So hi, my name is Jon Nordby. I'm as Morten said, the head of Soundsensing. We also are a recent startup. We have now just over 2 years, and we are currently a team of 4 primarily, and we have just hired a few more that are coming. So if we go to the next slide. Yeah, so our technology is designed for continuous audio monitoring primarily. We have developed an in-house sensor, or sensor hardware called DB20, which is designed for machine learning from the start. It can run either portable on battery, or you can install it permanently or semi-permanently. It's weatherproof, so it can be used outside and in harsh environments, such as industrial sites. It has integrated 4G data communication. And this means that you can just press one button, hold it for a few seconds, and it turns on, and you are live anywhere in the world where you have cellular connectivity, which is basically everywhere these days and getting better every day. So you can get started very easy, and you can use it in very demanding situations. And then it provides you with real-time data available both through an API, so you can integrate into existing systems, or you can use it directly on our data dashboard. And because we have designed this with machine learning, we can do a lot of interesting things without compromising privacy. And we have built a GDPR-friendly sound monitoring solution, and the hardware is designed and made in Norway. So on the next slide. Yeah, so the thing we work the most with is what's called noise monitoring. So all over the world today, human activity creates quite a lot of noise, and it's getting increasingly influencing people as we live closer and closer together, primarily in cities and urban areas. So if you are on a construction site, there are laws that you have to follow in order to make sure that you are not influencing the neighbors around too much. If you're in the office, it's critical to have a good audio environment so that you can enjoy concentrated work. And in industry, hearing loss is a serious risk in many occupations. And traffic is actually the biggest source of environmental noise pollution in the world. So it's also very important and tracked by municipalities and all the way up to the EU level. And there are also special cases in hospitality and especially noise-sensitive areas, such as schools or medical, where we operate. And you can continuously monitor. Right now, most of the measurements are done handheld by professionals, very high skill level. And this is costly and high quality, but reduces how much monitoring is actually done, which leads to a lack of oversight. So you might not spot that you have a problem. And this is moving now to more continuous monitoring, which is where we have designed solutions. So on the next slide, we are focused primarily on the hardware rollout the last 2 years. And now we're shifting much over to both commercialization of the existing solutions, but also to build machine learning models that really enrich the data that we can provide. And over time, we expect that more and more of the focus will be on software and the machine learning and the data and the quality of solutions that you can get by combining machine learning with data. And next. So one of the areas we work a lot on is called noise classification, which is actually part of my master thesis at NMBU. And we have further developed at Soundsensing and integrating into products and testing out and using in real life situations. So noise classification is classifying the noise that occurs in a audio atmosphere. So, and it's critical to understand why do we have a noise problem. So in the green line shown here, roughly in the middle, you see the sound level. And there are rules about what it needs to be, thresholds that you cannot exceed at night and day and in different circumstances. It's relatively easy to track once you have a continuous monitoring system up. But the next step, if you have too high levels, as you see here, a couple of peaks that are too high, is okay, why? What is the source? Who is responsible for improving it? What do we do? And then noise classification shown below in purple tells us what are the noise categories that are in. So you see in this case, the high peaks correspond very closely to train class. And this tells us that it's the train that we need to do something with in order to improve the situation, not the cars and the road that's nearby or people that are walking in the area and maybe talking and so on. And this is key to understanding and making an action which improves the situation. And next, we also work on noise event detection, which is even more detailed. So for example, we worked with cases tracking noise around a shooting range where it's important not only the overall sound level, there might also be restrictions in how much activity you can have and also what time of the day are you allowed to have activity. So then we can count the individual noises and put them up in a calendar view as shown below. And we can also ensure that the activity is within the timeframes that are allowed. And next, we are working also a little bit outside of noise. So with noise, we care about the sound itself. But in anomaly detection, or what's called condition monitoring of machinery, we care about machines. So we will actually want to monitor the condition of the machine by using sound. So sound is here a tool, a very important tool, but it's not the phenomenon of interest in itself. And we have done tests in commercial real estate where we have installed in technical rooms where you have pumps, ventilation systems, cooling systems, electrical systems all together in a room. Place sensors out there and tracked for anomalies. So anomaly detection will not tell you what is wrong or necessarily even that there is or know that there is something wrong, but it will tell you that something is definitely off. Something is considerably different from what it used to be. And that's then that is a signal that can trigger a warning. And you might then schedule, depending on the severity, you might schedule an immediate follow-up with a technician that will check it right away. Or you can just put this in as a priority for maybe the next round of scheduled maintenance. You can have an ordered list to go for. So in the next, we are working with a number of customers and partners across several industries to make this happen. And next, in the final slide, yeah, I think I would like to highlight that we are also expanding, and we are looking for, especially right now, people to help with our data collection and data curation process. We have a position out for sound hunters. So those that are interested in that should contact me at jon@soundsensing.no. You'll also find us on soundsensing.no webpage. So thank you, that's us, and I'm looking forward to a great discussion.
Great, Jon. So when you talk about anomaly detection, you also talked about different severity levels. There was some warning and something that could maybe wait until next available opportunity, and there was some crisis level. Does that come automatically out of the algorithm, or is that some other not learnable features that's added on top?
That's mostly a risk evaluation that our customers typically have to do. And some have, let's say, processes very established for this. And some are new to, let's say, semi-automated monitoring and are building these processes as we go.
Very good. Thank you, Jon. And then I would take this opportunity to welcome the other panelists back so that we have a discussion with all three companies at the same time. And I'll start out with one question to all. You're working on very similar technologies, but for different use cases. Do you collaborate at all? Do you see any opportunity to do collaboration across these fields? Okay, across this, what about you, Øystein? How are you collaborating with other people?
We don't collaborate with Nomono or Soundsensing yet, but that would be interesting because we share some of the same problems and we are all interested in audio, which is really cool. So I'm thinking especially, I think what can really lift the experience is spatial audio. And that's something that we can't do today because of the service is mono or stereo. So it would be really cool to talk more to Nomono and work together with spatial audio.
But you, Audun and Iver, at least you encourage collaboration since you do open source. How you talked about that you get expert opinion from the open source community, but from other companies, for example, sharing of audio data, is that something that you do? Would you collaborate with other companies at all? Iver.
I like to keep track of open data sets, and then when something useful comes with an appropriate license, then I will typically include it in our in-house data set. But we don't currently share this in-house data set.
Mm-hmm. And the reason is that it has a lot of value for you, I guess?
It has a lot of value for us, yes.
And what about you, Jon, about collaboration? Are you thinking about also expanding to other areas? In the the audience mentioned a company called Bedsensio that seems to do breathing for health reasons. Is that something that could fit your system?
Yes, so we have kind of a two level approach. So in some projects, we are just providing the data, let's say collection facility, the hardware and the data platform, and then project partners or customers in some cases deliver, like make solutions on top of that. So that could be a collaboration model with, for example, Medsensio, which I'm not aware of yet, but we have others that are doing that. We're interested in that. And then we also have this added layer where we deliver noise monitoring solutions, kind of turnkey to our customers. So we are primarily doing turnkey, but we are very open to being an enabler and to we have a platform, we have tools that others can use.
Good. A question that has come up several times is the relation between audio and image or video. So, Jon, Øystein, to what extent are you using the image or the video when you did the amazing Alexa example with putting it outside? How does video play a role in that example?
Currently, what you listened to was a prototype. It's not in our product yet, but this is something we're working on. And what you listened to was a sort of a pure unsupervised learning in the traditional sense that what we do is that we extract some feature vectors from the microphone signals. And then those features, they are chosen so that they will form two clusters. There's one cluster that with sound sources coming from the camera view, and the other clusters is from sound sources coming from outside of the camera view. And this is what we do. We do the clustering, and when we have these clusters, we can estimate the models, and we can suppress one cluster and let through the other. But we want to, of course, to combine this with the video, because we have the camera, really good camera, and we're a small team. We work tighter together, so I think we can do something really good when we get these multimodal inputs.
Right. And does it happen that you kind of detect the wrong cluster, that you only get the sound outside and not inside? Not in the live demo, of course, but in the trial period?
Of course, we have. It has made some mistakes. But when that happens, we analyze the data and we learn what happens, and then we modify the clustering and the model. So, but it hasn't really been consequently picking up the audio from behind and suppressing everything from in front. It has been like small mistakes.
Small mistakes we can live with, but of course no mistakes is even better. What about you, Nomono? Can you leak any of the details of the tools you will be offering as storyteller? So will it be a DAW plugin? I'm not sure what DAW plugin is. Maybe you can explain what it is, or a standalone software or a hardware device?
I won't leak any details, but I can give some insights, a bit more insights maybe.
Okay.
So we will offer an end-to-end solution, hardware and software. And the equipment out there today is kind of siloed. So you have hardware or you buy software, but we offer the whole package. So it's and we have this, well, communicating with the NRK. You just want one button for good sound. So that is kind of our vision here. So this is a portable multi-channel recorder. You can bring it with you anywhere. And you just press record, and you record your content, whatever it might be. And then it's uploaded to the cloud service, and all of the magic happens, and then you have beautiful spatialized, purified audio available. So I think that's maybe the detail level I would like to present.
The level of detail you can give up. So both you or Audun and I think several others mentioned collaboration with universities. You come from a university similar environment. You're seeking university employees that are graduating now. So how do you feel the collaboration between Norwegian universities is working out for you? First, Audun, and then we take the others the same question. So what can you get? What do you get out of such opportunities?
Well, we haven't really been able to do that much of collaboration yet. We have proposed a number of master assignments and so on. So we would really like someone to jump on that and collaborate with us on that. So we would like to do more of that.
And what about you, Jon? You're seeking at least new employees. Is the university giving you enough of the graduates? Can we teach them anything more so that they become more useful to you in the company?
Yeah, for sure. I mean, there's this is not just universities, certainly not just Norwegian universities, but there's this huge disconnect in how easy it is to learn machine learning models and algorithms and let's say training them and so on, compared to data and like working with data, curating data, quality assuring data. So that in the university and a lot of research as well, you know, the data set is something magical that someone has, you know, perfected and curated. Although we know that, for example, ImageNet has like tons of mistakes and it's like really, but it's not addressed. And a lot of the work in the company is that kind of work. And that those skills are not, they're not just really found in new graduates, and they're not even really found, let's say, in the open and best practices. These are things that we have to develop, not alone, but at least bleeding edge.
True. Then, but that means, so if you can think more of that there is some sort of class, maybe. Of course, you don't. The students that really come out of your universities, they learn some basic skills. And for example, you, Øystein, when you try to get more of the exciting students that are listening to this talk tonight, do you think the Norwegian students are good enough, or do you more look internationally when you hire? Or how can we make sure that the students that are actually listening know enough or has the best skills for your job opportunities?
I think definitely Norwegian students are good, but yeah, we are advertising our job openings internationally, but and we have employees who are working from all over the world. But of course, it's in some positions it's better to get something to work together with us in our Fornebu office in Oslo. But I've been we haven't been collaborating with universities yet in NEAT. I have a proposal out for a master students project, but I've been supervising many students before in my previous job, and that has been a really good experience, I think, because then you get to work with some student and the advisor, a professor, and you can work together over quite a long time on a problem. And that's very good for getting to know that student and to introduce that student to this field of domain. So my experiences from my previous company has been really good.
Do you have a similar experience, Jon?
We have some master's degree thesis that we have supervised, 2 now, and hoping for more in the spring or next round. But also like encouraged, like if anyone isn't interested in learning the data part of and then there is a student, it doesn't have to be pure machine learning either, but you have some interest in sound, hopefully if you listen to this podcast, and then you will get in contact with us, because that's what the sound hunter position is. Like, no one actually in the world knows how to do it. So if you don't know how to do it, that's not a problem. We will learn it together. We will become what we need to in order to succeed.
Good. It seems that you're all excited about student collaboration. That warms my professor heart. And a question that often comes up when you interact with systems such as this is privacy. So, Audun and Iver, is that something you discuss? Have you had a privacy breach in your data collection, or is that not relevant at all? Iver.
I am not sure if I understood the question.
But when a person uses your software, you will collect. You said you collect data, right? And potentially there could be very privacy-related data in that, or privacy-related information in that data. How do you consider? If I use your software, how am I sure that this data is not used or trained or breached in any way?
First, our dataset consists of mostly data that I find that's openly available on the internet, but it's filtered and curated. We listen to it manually. We haven't taken any customer data and put it on in their dataset, but we have some in-house recordings made by our employees that we include there. So, so we haven't had any privacy breaches in that way, if that answers your question.
That it certainly does. What about you, Øystein, who are incrementally learning? So that means that you're collecting data as we speak. Are you collecting data now from me?
Yes. Well,
okay.
Yes, but for the demo you saw earlier, that was to remove sound sources that are behind my system. So I don't want much the audio from your end. But what we do is that we do the learning that we do today is all unsupervised and it's happening on the device. And as we talked about earlier, we put most weights on the most recent audio and we forget the old. So the old data will be gone away. It will go away pretty soon. So we don't really have that issue now.
Good. And Jon, if you can give an advice to anyone that wants to do a similar startup like you, yeah, from an academic point of view, maybe there's some master students that think, I want to be like Jon. What steps should I take?
I think that go for it. Like, the decision to start is the hardest, so try to find an environment where you have people that support you around. Like, you don't go alone. This is like no company, even though like a one-man companies or one-woman company is rarely a single person. You know, you have people around you, mentors and so on. So reach out to those communities if you have them at your university, or if you don't have it, go to incubators that are around, or existing startups. Maybe join a startup before you start your own. That's also, maybe a trick. See if you actually like it.
And what about going to a university, saying, here's my idea, could you help me? Is that something that you recommend?
Sure, you can try, but the idea itself is not that's very, you haven't started. You're far from having started. So it's of course a part of the puzzle, but it's really, but definitely share your idea with people and test it. Like, if you have an idea of who the customer is, who this should help, maybe not the customer, but at least who it should help, or how it should help. Talk to them and see, like, is this something that could help you? Is it something we're interested in paying for? Right. And test your idea.
And when you're talking about buying, that what always comes up is funding, either from investors or from Innovation Norge or Norwegian Research Council, Innovation Norway. Is that opportunities that you're using, Audun? Innovation Norway or Research Council Norway funding? And if so, or if not, why not?
Absolutely. We have had huge support from Innovation Norway, and also having projects funded by the Research Council. So that is of huge help, especially in a quite an early stage, and then especially from Innovation Norway.
And what about you, Øystein? The public funding opportunities, are you heavily using those, or is?
No, we're not using those at all.
Why not?
We have some private investors that it's sufficient for us. It got us started, and now we are the business is going really well now.
Okay. That sounds amazing that this is happening, because I understand from the panel here that the sound industry is very conservative. Do you see those existing sound companies as competitors? And do you think they will be able to adapt to this new machine learning based world, Øystein?
Of course, we have many competitors in the video conferencing industry. we do, it's not only sound that we're doing video, and we're doing the whole video conferencing system. So we have many competitors, and some of them have adopted some machine learning methods, but I think many of the old ones, they are sort of stuck with the old signal processing. They have a lot of legacy code, maybe, that it takes time to transform that to a pure machine learning based. So this is really what we have done in NEAT. We have started from scratch, written everything from scratch, and everything that we have done has been with machine learning in mind. We wanted to implement something that was using pure machine learning algorithms. And of course, it's some signal processing, like for feature extraction, but it's a whole different paradigm, really.
Right. It always reminds me of the famous Napoleon saying that you should never combat the previous battle. You should always look for a new approach, new opportunity. So if you're listening to someone now and trying to implement that, you're kind of playing the old game. So how are you able to then stay in front in a successful way that you're doing? If you start with Jon, how are you looking for new opportunities in the sound domain?
Yeah, so we have some quite conservative industry that we serve, especially acousticians, engineering consultants, and so on. They have their ways of doing things, and it's some of it's in standards, it's established, but there are, like, in all, not say all these companies, but often you have someone that is a bit less conservative than the rest, and it's about finding those key people, key companies that are interested in trying new things and that have a hunger for trying, and they are usually very receptive. And we've found that in several companies. We were actually surprised. We thought that we would be competitors with, let's say, acousticians, but actually they are very enthusiastic about our products and using that. So that's actually one of our main customer segments.
A bit of a technical question that came in. Are you? I think this is for Øystein. Are you able to tell the actual direction of the audio that comes in, or are you just saying it's out of scope?
We cannot tell the direction, no. It's just clustering, and we have defined these two clusters, and that's what we do. And if I can answer another question that came into was how can we forget old data? There was a question about that, which is very interesting, because what we could do is that we could take all the audio data or all the audio samples that came in from the beginning of the meeting. We could use that to train the model. But instead, we could have a sliding window. We could have like 30 seconds back in time, and we can train a model on only that data. And then we can get one more data sample, and we can remove one data sample. So that's one way of doing it.
That must be very groundbreaking. It seems very challenging to do that. So very amazing. There's a challenge that's come in for you, Øystein. I'm not sure if you're up to it. And that is a panelist or one attendee asked if you can go back to the sync and tell a joke or even say hello. Is that something that you're willing to do while we ask Audun and Iver a question? Did you understand the question?
You mean the same demo as I did earlier, and then?
No, because you have a sync in the background.
Oh.
And I think the audience is interested in hearing if you can also hear you from back there, or if not.
Okay. Yeah. Well,
it's okay, or we can do it later. It is more appropriate.
Yeah.
Okay, let's do it.
I can do that, but then if I go back here now,
we're having a live demo.
You can still hear me, right?
Yes.
I'm all the way to the sync.
We can still hear you. Perfect. So then we had a good demo of excellent opportunity of your product. So we're rounding off. 5 minutes left. I would like to ask everyone in the panel the same question, and this is: how do you want NORA.startup and NAIL to best support your work in the future? So it can be anything. But can you think of anything that we should do or we should start doing? Let's say 5 years from now, you have an excellent collaboration with us. What does that look like? For example, Audun, what would that ideal situation be 5 years in the future?
I would really like to see that we are able to establish a cluster on this. So starting with an arena application to Innovation Norway, I think that could be a very good start. Building on what we have here and maybe expanding it as well. There is a lot of audio technology in Norway, so I think that would be really good.
Like a cluster where within NORA or NAIL that we have audio machine learning as a specific topic, maybe arena application would be one opportunity. Great. What about you, Jon? For example, we have summer schools at the NORA. Anything that you could look for in either NAIL or NORA collaboration?
Yeah, I think the opening up for collaboration is important, and connecting. So sometimes I don't know who is working in basically the same space that I'm in. And sometimes it's funny, I have greater visibility to the outside world, like maybe New York, Barcelona, or high in London. And not so much Norway. So that just visibility is great. And I think the cluster idea is new to me, but I think that's maybe the scale where NORA collaboration and so on could make sense, like to really build that kind of long-term, large-scale entity for collaboration.
And good. And then Øystein last. Do you hope that we still use Zoom as much after we all get our vaccines? And everyone, when that has happened, how do we foresee a NAIL NORA collaboration with you potentially?
I think definitely people are still going to use video conferencing technology also after the pandemic. Definitely, it's going to be a hybrid world, we think, where every meeting is going to be a video meeting, we think, because some people will always be remote.
Exactly.
In all meetings. So I think this is come to stay.
Exactly. So that's what I see as most challenging. So only Zoom meetings, fine. Hybrid, when somebody is eating potato chips, as you say, challenging, right? And the collaboration, yes, I said.
Yeah, well, I think it's AI and machine learning is going to be very important going forward. So anything that we can do to motivate young people and students to study this is good. And holding webinars like this, and and also having projects together, so we can have students that we can supervise on problems that we face in industry. I think this is going to be really important.
Great. So you're all open to collaboration, either as a type of joint project of some sort or student collaboration that bounds well both for NAIL and NORA. And this concludes this webinar where we've been talking to Øystein Birkenes from NEAT, Audun Solvang and Iver Jordal from Nomono, and Jon Nyrby from Soundsensing. This has been a NAIL and NORA webinar collaboration and start of what we call Gullrekka here on Friday. So weekend and taco comes very soon. Thank you.